Happy Halloween, people. I hope you're doing well, my lovelies, so let's celebrate the season with something that may contain science. Haunted science. As scientific literature has thoroughly established, the moon is haunted. No need to look it up in research databases, just trust me. Moon? Definitely haunted. Scientists don't know how the moon became haunted, in part because we don't know exactly how it was formed. There are multiple theories, but most do share a common core. About 4.5 billion years ago, something crashed into the Earth, knocking huge chunks out of our homeworld and creating a debris ring that eventually coalesced into the moon. The compositions of the moon and Earth both support and challenge traditional takes on this giant impact hypothesis. On the one hand, the moon's geologic composition is incredibly similar to our own, though it has diverged since it became its own little celestial body. On the other hand, the moon is so like us that it's kind of weird. Sometimes scientists expect that if an entire Mars-sized rock hit the Earth and knocked a whole moon out of it, that energy would have stripped the moon of its volatile elements, and yet they're surprisingly plentiful. And yes, if you're keeping track, that means the moon is both haunted and volatile. It's a bad combination. As the origin of the moon indicates, scientists rely heavily on geological composition of solar system bodies to extrapolate early events like these in our solar system. We saw that a couple weeks ago, when the presence of iridium, which is common in asteroids but uncommon on Earth, gave us a hint about the meteor strike that ended the dinosaurs' whole career. Researchers learn a lot from studying the mineral composition of the rocks, where the rocks are, and how similar their composition is to other rocks in our solar system. By combining that geochemical information with the orbital dynamics of those rocks, astronomers can reverse engineer the history of our planets and asteroids and how they first formed. But what if that information gave us more haunted, volatile moon than we bargained for? Well, so it is with this study published in the journal Communications, Earth and Environment, which found that one of our local asteroids is surprisingly, even suspiciously moon-like. Her name is Kamo'o'alewa. She's a little beb, just 46 to 58 meters across. I got you, Freedom Unit enjoyers, that's about 150 to 190 feet. Her name is Hawaiian and means the oscillating fragment, as in a fragment that chipped off a larger object. Unlike all those asteroids way out there in the belt, Kamo'o'alewa is right in our backyard. If Earth's orbit is that blue circle and the red circle is Mars, always on brand Mars, I respect it, Kamo'o'alewa's orbit is the white circle that kind of, but not quite, intersects with ours. Now you might be thinking, Sam, should I be concerned about the points where that orbit intersects with ours? And you wouldn't be wrong. At its closest, Kamo'o'alewa comes within 0.033 astronomical units of Earth, where 1 astronomical unit is the 8 light-minute distance between us and our sun. Of course, even very small numbers like that still represent an enormous distance in actual space. That 0.03 AU is almost 5 million kilometers and 13 times the distance between the Earth and Moon. So, does Kamo'o'alewa come pretty close to us? Yeah. Is close to us still plenty far enough away? Also yes. But it's still a weird orbit, all things considered, in a weird place in the solar system, and that's the big reason that astronomers have been studying a little rock that might otherwise be just another asteroid. 2 years ago, a group of astronomers decided to perform spectral analysis of Kamo'o'alewa to determine its composition. After all, we know that geochemical composition can tell us a lot about a rock. Spectral analysis yielded a reflectance somewhere between zero.4 and 2.2 microns, which apparently typically suggests silicates, but not the usual ones we see in inner system asteroids. That 2021 study then compared its composition to a bunch of other minerals and objects, and you know what matched? That's right, the moon. Fragment of a larger object indeed. And that brings us back to this study, which attempted to model whether Kama'o'alewa really could be a chip off the old moon. Using numerical simulation, Renu Malhotra's research group tried to figure out whether, if you knocked a piece out of the moon, you could end up in an orbit like Kama'o'alewa's. And according to their calculations at least, if a meteoroid impacted the moon, it could spin off a fragment the size of Kama'o'alewa's into the orbit that we observe it to have. Now, over its billions of years, plenty of rocks have impacted the moon. That's how it got all those cute little cheese holes. But usually when impacts launch bits of moon rock all over everywhere, those bits either fall back to the moon or they fall to the next closest gravity well. You know, us. But Kama'o'alewa somehow got herself knocked way outside our Hill sphere, which is to say, our zone of local gravitational dominance. Gravitationally speaking, Kama'o'alewa doesn't answer to us, she answers to the sun. Kama'o'alewa's orbit is pretty much the same period as ours, despite her different eccentricity, making her one of 7 of Earth's known quasi-satellites, and the one with the most stable orbit around Earth, where she's projected to hang out for at least the next few centuries. From here, our scientists hope to determine the exact age of Kama'o'alewa and to pin down the specific conditions that allowed her to run away from our local orbit and become a free and independent moon rock. They even hope to identify the particular impact crater on the moon that initiated Kama'o'alewa's origin story. Had Kama'o'alewa not had such an unusual orbital dynamic, astronomers never would have looked at her composition and discovered that she's likely made of moon. And it makes you wonder, how many other asteroids have an unusual origin that we simply never thought to investigate? After all, as this study's simulations illustrate, if a lunar impact can spin off a rock like Kama'o'alewa once, it could have happened again. Who knows how many other haunted pieces of moon are out there? Hiding. Biding their time. Waiting. Happy Halloween!